See in 100 seconds. Binary trees. Watch the struct on line 4. See 2 pointers, left and right instead of just next. Each node can branch in 2 directions, forming a tree. See create node on line 10. Both left and right start as null. A new node is a leaf with no children. Watch insert on line 18. See line 19. If root is NUL, we have found an empty spot, so we create a node there. That is the base case of the recursion. See lines 20 and 21. If the value is less than root, we recurse left. Otherwise, line 23 recurses right. Each call moves one level deeper until it finds NUL. Watch in order on line 27. See the pattern? Go left, print the current node, then go right. This visits every node in sorted order. That is what makes it a binary search tree. See count on line 34. Watch line 36. 1 for the current node, plus count of left, plus count of right. The recursion adds up every node in the tree. Watch free tree on line 38. See the order. Free left first, then right, then the node itself. Children must be freed before the parent, or we lose access to them. See main. We insert 50 as the root, then 30 goes left, 70 goes right. 20 and 40 branch off 30, 60 branches off 70. 6 nodes, 3 levels deep. See the output. In order prints 20, 30, 40, 50, 60, 70. Perfectly sorted. Count is 6. The tree structure kept everything in order, and in order traversal reveals it. Next up, binary tree traversal.